Hi folks, we're going to take a look at page 370, number 11. Okay, so let's take a quick look at the question. It says an airplane is traveling north 60 degrees east with a resultant ground speed of 205 kilometers per hour. Okay, so here, telling us traveling in this direction, it's not immediately clear whether we're talking about the air direction or the ground direction, but because they tell us the resultant ground speed, okay, this indicates that this is where the plane is actually flying. Okay, now in the second line, they make that even clearer. They say the nose of the plane is actually pointing east with an airspeed of 212 kilometers per hour. Okay, so one of the important things in these questions is to understand what information they're actually giving us. And they want us to determine the wind direction and the wind speed. Okay, so let's start by having a diagram here. So this 205, so north 60 degrees east. Okay, so north 60 degrees east, north 60 degrees east is going to look like this, okay, with a magnitude of 205, okay, and this is going to be the resultant velocity, okay, so the resultant is going to be the sum of the air velocity plus the wind velocity. So the air velocity we know is 212, so a little longer than that there. Okay, due east. So that means if I add the air velocity and then to that add the wind velocity, this is going to be my resultant. Okay, so important to know how we're adding this up. Okay, so this represents the air velocity and this represents the final or ground velocity. Okay, so let's get rid of the textbook and solve this problem. So they want to know the wind's speed and direction. So essentially they want to know this wind vector. Okay, let's make this clear. This is a G for ground and this is A for air. Okay, so let's go ahead and do that. Now I've got two sides of this triangle, so and since I'm looking for the third side, I should be looking for an angle. And this is where here this 212 vector is nice because it's going along the east. So if I know that that's 60, this angle inside should just be 30 degrees. Okay, so it looks like the one we can find first is, let's use the cosine law to solve for the magnitude of VW. Okay, so magnitude of VW is just going to be equal to square root, and we're just going to apply the cosine law. Okay, so 205 squared plus 212 squared minus 2 times 205 times 212 times cosine of 30, its opposite angle. Okay, so we should be at the point where we're doing this almost without thinking. Okay, and we should also be really clear on how we're inputting this into our calculators. Okay, so square root of 205 squared plus 212 squared minus 2 times 205 times 212 times cos 30. And looks like we've got 108.1. Okay, and that's going to be kilometers per hour. Okay, so we have the, so I guess in fact, since they're asking us specifically about speed and direction separately, we'll give this here as a speed right off the bat, kilometers per hour. Okay, and so that's the wind speed, so quite strong winds. Okay, so now let's look for the direction of this wind. Okay, now the fact that I made a point of drawing this second one a little longer gives me an idea that I should be in that sort of northwest direction. Okay, but that'll all be confirmed, so let's find this angle here. And again, as usual, I'm going to opt for the cosine law anytime I can. Okay, so that's going to be inverse cosine, inverse cosine of, so I first look for its opposite side, which is the 205, so that's how I'm going to have the 205 squared, and then subtracting the other two sides squared. Okay, so it's going to be minus 212 squared minus 108.1 squared all over negative 2 times 212 times 108.1. Okay, and now let's input that into our calculator. Okay, so inverse cos, open up a bracket for the numerator, so 205 squared minus 212 squared minus 108.1 squared. Close off the numerator, divide, open up the denominator, negative 2 times 212 times 108.1, close everything off, and here we have 71.4 degrees. Okay, so our wind speed is given by this here, and our wind direction. Okay, this is just an angle. We have to now give it as a direction. So here we can say it's west 71.4 degrees north. Okay, so west 71.4 degrees north, or of course you could give it as north and whatever that angle is towards the west. Okay, so again, just to recap this problem here, the main thing was to understand that this vector here had to be the resultant vector, meaning that the air velocity and the wind velocity had to add up together to give us this resultant velocity. Okay, that's it for this one.